Uh, I welcome Dr. Anil Kumar to this FTP. Dr. Anil Kumar is having 30 years of experience in IT and related field. He graduated from BTech Computer Science and Engineering from TKM College of Engineering, University of Kerala, and MTech in Computer and Information Technology from Indian Institute of Technology, IIT Kharagpur, and PhD in IT Risk Management in Banks from Cochin University. And he has a wide experience starting from a probationary officer in bank, then 7 years in as a lecturer in computer science and engineering, TKM College of Engineering, followed by IT manager, chief manager IT in a bank in Dubai, UAE, chief operating officer, Dimensions Financial Technopark, technical consultant, technical advisor, IT consultant, chief technology officer, and presently he is holding more than 4 positions at the same time. Moreover, he is the member of board of studies CSE also. And his wide experience, vast experience will be anyway, will be an will be something to be utilized by the participants. That is why I request asking questions. So many questions he can answer very well to the questions also, because he has that much wide experience. I welcome Dr. Anil Kumar to this FTP, handing over my to him. Thank you.
Thank you, Salim, Professor. So thanks for the nice words. so, actually, I was supposed to be there in the introductory session. So unfortunately, I could not take that session yesterday. So this is the second one. So, I'm thinking like I'll combine both the introductory session I was planning to take you through how software engineering is applied in the industry, like in each stage of the software development. How do we do things, and then what is the gap? Why is always there is a gap between what we teach the students in the colleges, and then when they go to an industry, there is a difference, right? So I'll just highlight some of those gaps and why is it happening, and how you can probably, as an additional course material or assignment or as part of the project, how can you, manage these things so that the students will be more capable and skillful to join any industry. So that's the first part of it. And then the second part of the session today was about DevOps, CI/CD, Dockers, Kubernetes. So I'll also, highlight you on those. Why is it required, and why do we do that, all together? So I'll present. This is how it goes. Like I'll present a slide, and few things are in the slide, and then I'll also take you to some of the real documents, or supporting project related documents, which will tell you how important each of the stages are. So that's the idea. Shall I share my screen?
Yes, you can continue. You can show your slides also if it is
So just as I said, like block, you can stop me anywhere, like, and then
yes.
we can do it. Let me start this. Okay, so this is these are the two things, as I said, I want to cover today. So one is a brief overview of the software engineering and its management. So it's mostly I'll tell you how it's happening inside the industry, and the other part is the DevOps practices. Okay. So this is my objective, basically. I have not seen your textbook. I don't want to take you through the textbooks, or I don't want to take you to any of the theory or any of the things which you normally do. So I just want to tell you, like, there is some gap, and software engineering is a core paper where, that's where the students should get everything connected, whatever they learn in different subjects. So this is what I want to touch upon. So let me start with requirements. So when you start developing a software, the entire thing happens. I think I'm audible, right? Is it okay? Anyone?
Yes, yes,
Yeah,
yes.
okay. Thanks. Okay. So, so everything start with a requirement coming from a customer, who would say like, or, a department which want to implement something, which is using a software. So it involves three things like, collection, and then you analyze it, and then also you document it. So here is how we get requirements. Like, if you want to see the sources, it could be like a discussion wherein the customer tells us, okay, I want to automate some of my HR activities. So like, recruitment or onboarding, attendance, leave, payroll, end of service, any of those things. So this is where, sometimes on a discussion, or when you already have a customer, they'll come and tell you, okay, we need these things. And the other is like, you may get emails from a prospective customer saying that, okay, I want to make, these things, these changes. And the third thing is, some of the companies, professional companies, when they really want a software to be developed, they create an RFP, it's a request for proposal, which they share with the companies, and companies will submit a proposal, and that goes from there. So the first part is I want to talk about is the sources. From various sources, you get the requirement. Once you get the requirement, normally it will not be clear normally. So what we do is there are two options. For some customers, we write the queries. We ask them, what is this? How is this? Like, if you have any questions, or something is not clear, you send them a queries. And then also we can request a meeting with them, like wherein their business team will explain what is the something, which really they are looking for. So those are the meetings. And then some cases, if the system is too complex, you can't just make out it, by just having one or two meetings or by seeing a document. In those cases, we propose to have a system, study phase, wherein we'll allocate a resource. That resource will go and create, study the business requirements, and create an SRS, software requirement specification, or otherwise we call it as functional requirement specification. Now, why is it important? So I just want to, take you to two viewpoints. Like, one is uh, this part of the software engineering is important because, if you know this part, you can become a business analyst. Basically, there are people who do analyze the requirements, and they become the business analyst profession. So this requires two skills basically. One is you need to know the business domain, like if it is banking, insurance, or whatever domain, healthcare. So you may need to know the terms, terminology used in that particular domain to understand what is the business. And the second is you also need to know some technical knowledge. When you collect the information, finally it need to translate into a technology or an implementation. So, each part of the things you learn in software engineering, there's a separate role in the industry. Like, starting from requirement analysis, you have a BA, which is a business analyst. When you move to the next part, you have, let's say, design. There are architects, technical leads, and people. So every stage has a corresponding role too. Just to highlight that, I just told this. So one part of it, and the second part of it is like, how do you now make sure a student can go and do this? So, currently, if you see your projects or your assignments or your lab, you never ask a student to create a requirements document. They have never seen it, right? So that's one gap where, when they come into the company also, they don't know what is a requirement document. So give you some of the samples. Like, let's say this is one of the requirement I recently got. You can see like the client want to send their data to another system using HL7 syntax. This is an international health protocol, HL7, and they gave a reference also, and they're asking us, can we do this? They already have a system which is a survey system, and when you do a patient survey, they also want to push that data to another system using this format. So when normally you receive a requirement, I just want to stress the point here is like it is so small. Like you see, this becomes a project for 2 months or 3 months, depending upon the volume. So you just cannot go and start coding it, because you need to expand this. You need to understand actually how, what are the other business requirements, how the protocol can be implemented, what are the challenges in it, risk in it. So it takes time to develop the software requirement, actual specification. Okay. So the second requirement, just one liner. Can you do sentiment analysis on our survey data to find out these three things? So basically, it's a patient doing the survey for their doctors. Okay. So they want to see in their response in the survey, they talk about, are they talking about competence? Are they talking about compassion of these doctors? Are they talking about communication? How was their communication? Okay. So normally we call it as 3 C's. So on this, I want to, identify from the text, like let's say the doctor was, an expert doctor. If that was a comment, it shows his competence, right? So the competence sentiment will show it as good. That's the result they are expecting. So now you have the text, the data, which are not formatted. There'll be a lot of junk in that. You need to clean the data, and then you need to apply. You cannot simply apply sentiment analysis, because, sentiment analysis, when you take a text data, it just gives you what is the overall sentiment. Okay. Now in this, you want to segregate each sentence. In each sentence, you want to still find out, are these patients talking about any of these things? And if yes, what is it? Okay. So these are some of the requirements examples I just wanted to point out. Will we go to another example? So this is a RFP document. You can see that. So here it is more professional, more detailed, wherein they have given us more information. Okay. So they give us what is the purpose of this requirement, what is the scope of this work, and how it should look like. A lot of details will be given in the, so they clearly define the scope, okay, and technical requirements, non-technical requirements. So this kind of documents normally we receive from industry, enterprises who have a clearly defined process, and they have people to make this, and they know exactly what they want. Okay, and they give us all the condition also. How do you submit your proposal? What are the things to be included in that? What is the date? And if they have any preference on the technology, they say like, okay, we want open source technology, or we want to use .NET, they specify that. And this is quite a lot of information, which they give, and they also give the dates, when I can give this a response to this, and what is the time frame by which I will know, like, whether I am selected or not. A lot of things, dates, everything is clearly mentioned here. Okay, so these are some of the projects where you get something called an RFP. I specified it somewhere, which is a request for proposal. Now, this is another one. This is a mobile application requirement. They specify like, the login process. In that page, they need a registration and how it should be processed. Once it is logged in, where it should go, and what should be the landing page, the home page requirements. So why this is important is basically, so this is a requirement. It defines the scope, first of all. Okay. Now, why is scope important? We do the estimation, or we do the pricing based on the scope. And why, again, that scope is important? We deliver the software based on this scope. So if there is a dispute, you have the scope clearly defined, and the deliverables should match with what is there in the requirement document. If there is a variation, or if they are asking more, the agreement says, okay, this is what we can deliver within this time, and this is the cost for it. So you have a clearly defined requirement document, which helps you to go through your next steps, the successive design as well as quality testing as well as the other deliverables. This is another one. So these are some of the examples. RFP. Okay, so let me go to this. So this is an example of a query where the client, customer wanted an ETL tool. ETL is the extract, load and transform and load, ETL, right? Okay. Tool wherein they want to integrate some data sources and create a common dashboard. Okay, so they just gave only that much. So we replied back with what are the data sources for integration, and for each data source, what is the type of the data? So is it a database from where we need to take the data? Is it SharePoint, or is it some other application? Or do we have APIs, from where we can get the data, or it is web scraping? What is the kind of data source we have? And then what format the data is? Is it some images, video, JSON? What kind of data you have? And where is this host system? Is it on-premise on the same network or on cloud? And how can we connect? Do you have a gateway? Do you have a direct connectivity to this particular one? And what is the volume? Is it in MB, GB, or Tera? What is the size of the data? And what frequency you want to sync it? So normally, if you don't understand things, normally send you a query. This is what I said in the second steps. So you get the requirement. If it's not clear, you ask for a meeting or you send some queries, get more information, and then document it. So this is a slightly more enhanced set of questions. This is for a database migration project, wherein we ask, what is the current installation, what is the versions used, what are the environments you are in, what are the ports open, what is the dependencies, like is it connected to any other systems? All these, questions are asked here. So this is how, in the first stage itself, we get a clear picture of what is the requirement of this particular software. Okay, any questions? Please be free. I just wanted to show you, how really it happens. That's where I'm focused on. Shall I continue? Okay. I hope somebody is there, right?
Yes, sir.
Okay. All right. No problem. Okay. So, so that once you have it, the next step is you want an SOW. Basically, as I told you, we need to define the scope of work or the statement of work. So that is the next step. So we know these are the things to be done. Okay. So we create, normally it's called an SOW. Now, based on that, we create an estimation. So we will compute like how much of development is required, how much of testing is required, how much of architect level engagement is required, how much of project management is required. So we do estimate the hours. And then once that is ready, we can find out a costing, like how much it is going to cost for the customer to build this particular software. And everything put together, we create a business proposal. I'll show you some samples on business proposal too. And then once a proposal is sent, if we got the project, let's say they agreed, okay, you can go ahead with, or they awarded the project to us. The next step is there will be a set of agreements. This is where, once there is a dispute or any other issues come up, this SOW as well as these agreements will prevail. Basically, you look into that and then resolve the conflict. So one of that is like, normally we call as a purchase agreement, which, like in college, if you are doing any of the purchase related activities, there will be a purchase agreement, or we call it as a master services agreement. And then normally, since you deal with their data, you connect to their network and you have access to their systems, there'll be a non-disclosure agreement, which tells you, like, you make sure, you or any of your resources who work on this project whatever data they get over the period of time will not disclose it to anyone else. So that we give an agreement to them. We don't do a disclosure, and then SLA. So once we did this, software, what is the service level agreement? If there is a problem, within what time we will respond back to them and resolve it. So creating a software is one part of it, and then maintaining it is the second part, wherein you need to make sure, okay, you get necessary support from the vendor. So this agreement says, what is the time frame at which you can get a response and how they resolve, etc. And once you bought a software, AMC is another contract, wherein, let's say, they want to do the regular maintenance, support, etc. What is the cost and what are the terms and conditions, which we normally put in AMC. So, see, just before a project starts, a lot of things are done. A lot of documentation is done to make sure, end of the day, you deliver the right requirements, as well as you don't jump into, a dispute. Then once this is done, normally you get a purchase order issued, and also probably you'll get the advance payments. Probably, first advance, probably 30% or 40% of the total project cost. The customer will give it to you, wherein you start to kick off the project. So let me go through an example for this software. Tell you. So these are the terminologies they define, and I just changed some of the names, etc., client and other things. So you can see here, the scope of work is defined on each of these modules, software modules like customer, share, loans. What other things will be covered under this particular proposal? So scope is already there, and there is an overview of the architecture. How once you build the software, how it will look like? What is the front end, middle tier, as well as the back end? And what are the security features included in this application already? The security things. Then it goes to these are their product benefits. What are the any integration required? So the software need integration with SMS gateways, emails, payment gateways, mobile apps. So all this is taken care here. What are the integrations supported? And do you need multi-language for this particular software? And do you need to support multiple currencies like dollar, INR, or whatever currencies you want to support? So that is specified here. And what is the compatibility? When you have the software, it can run on Google Chrome, Mozilla, and Internet Explorer with certain versions. So that is also specified. And what is the approach of solution? How do they do that? So they develop this in this is a .NET project. So Visual Studio is a tool used. .NET Framework is 4.5. SQL Server is the database, and architecture is like microservices. So all those details are there. And any other third-party component they use, it's also listed. Technology, architecture. Okay, it's all about microservices. Cool. And the API gateways. Once you have APIs connecting, what are the API gateways, and how is that structure looking like? The end users connecting to an API gateway, and from there it goes to each of the microservices. From there it goes to the database. So this overall microservices thing. So it has all kind of architectures, diagrams included in this. Like you can see, it comes to a firewall. From the firewall, it goes to the app server. From there, it goes to the core banking system or the underlying database or the data. So now, once the system fails, what is a business continuity process like? Now, do you want to set up a DR site, disaster recovery site, or backups? The procedure is also mentioned here. How can you ensure business continuity? And now coming to the project, what is the process of change management? If you want to make some changes, what is the process to follow? You can see there will be change request. They do an impact analysis. Once impact analysis is done, submit the change to the control for approval. And if the change is approved, and then go and implement it. For that, you will have all the schedule, effort, and cost. If it is not in the scope, they charge extra. So change management has a separate workflow, how you do it. And how you give the training to the customers, training management, okay. Support and ongoing maintenance is what I said, like support and maintenance. And here is the SLA management technology. So, how they are going to attend the different kind of escalations or incidents. So in the tier one, how it is, it can escalate to tier two, tier three. So all the processes is explained here, escalation matrix. So you can see that the proposal includes everything. It's not just like the code or the logic or just few items like that. It includes everything. And finally, when you want to host your system, what is it going to be? Okay. And the payment aims, you can see that what is the warranty provided this project. And then it also says payment terms, as I said, like, along with purchase order 50%, and after that 25. Okay, so that's about a project proposal. This is another one, I guess. Again, it's a project proposal with for an app. Okay, so let's leave that. So this is you can see, like, it's an SOW. Okay, so once you this is the other way, you say these are the work you're going to do. Looks like a complete agreement. Again, scope of work, solution, prerequisites, different milestones are defined. What are we going to do in week 1, week 2, week 3, week 4? This is just 4-week project. Okay, and what is the amount, like, for each of the resources, like for a Power BI developer, hourly rate, what is it? And then what is the daily rate and what is the monthly rate? It's a resource model. And for Python developer, it is different. For architect, it is again different. So it goes on, like you can see, like escalation matrix, same. Who are all the roles where you can approach if somebody is not attending your, fix, and other terms and conditions. Okay, so that's another one. Okay, so let me go to the next step, which is basically estimation. Now, if you see here, I think you already had the Agile class already over. So, like tickets, in Agile Jira, you create, tickets in Agile model. So this is a module and you have a ticket and this is what you have to do. So, we go and estimate how many hours it is going to take. So for each of these functionality, ticket or a card, the hours are estimated. Now, estimation, there are different techniques for estimations. This is mostly on the experience of the, I would say team lead or the technical lead who reviews this, and then they compute the total hours. Sometimes it is, we put the total hours. Sometimes we also put, for creating this particular, let's say login page, we need to create a GUI. So we'll say front end, we need so many hours, and then it connects to the backend through an API. Okay, so we'll say for API development, this is something middle tier. And then on the DB side, we may require procedures or other things. So we normally give those things and then sum it up. You can see, like, total development hours, it says, okay, 98 hours. So, developer, there will be some rates. I put some sample rates here. Like, let's say if the developer rate is $20 per hour, so it will become, 98 into 20, we compute how much is the development effort and what is the cost. Okay, so we're talking about the estimation. Now, this is not all. Like, when you develop a software, there are a lot of other activities too. So you need to do testing or QA. So we'll estimate, what is the QA effort. Normally it is 10, 15 or 20% of the development time. So we calculate that, there will be a rate for QAs, testers, and then we'll get that rate. And there'll be team leads who does the code review and, guidance to the team, etc. So what is that? And system analysis, as I said, BAs will be there. They'll be putting some hours. And then once the system is ready, there'll be, load tests sometimes. requested by the client. So we do that, and what is the hours and cost for that, and project management. So this is how, like, when a project comes in, the total cost, will be computed based on each of the roles, like developer, QA, PA, and then PM. All that is computed together, and finally we arrive at a cost. Sometimes we also add a buffer like 10%, because there will be always, you can't get all the details upfront. So there can be some buffer which normally we add, and then get the next slide. It's going to rain. Okay, so that's one. You can see this estimate. You can see, like, for example, this is common one, authentication. Okay, so for this app, for the authentication, login, change password, forget password, and then internally you also want the access log. Okay, to implement this, you're saying on the website we will require this many hours. If you are using Flutter, this web, this, so it has more, details. Same, like, it goes on, and then we finally get the hours. That's about estimation. Okay, so I give you a sample of master services agreement. You can see that it's such a big document. It includes all the terms and conditions, basically, about the personnel involved in this, non-solicitation, and client's responsibilities, fees and expenses, what is the payment schedule. It goes on, like, and IP, if there are any intellectual property, how do you preserve that. So terms and conditions for that goes to warranties, confidential information. How do you handle that? How do you access the network? Their access thing. Terms, termination. How do you terminate this contract? And then indemnification. Limitation of liability. Now, if something goes wrong, like, you did a software and it caused some big loss to the company or to you, so how do you limit it? Normally what we do is the limitation will be like, whatever is the payment made or whatever is the cost of the project, that will be the maximum amount you can charge the vendor, basically. So you put some limitations on you can't pay so much, right, if something goes wrong. And any regulatory things, just to show you, like, such a big thing with a lot of conditions, terms, all that included in the master services agreement. And then end of it, normally when you do the first project, along with the MSA, master services agreement, you also include the statement of work for that. Okay, that's it. This is an SLA sample, wherein, once you do a business with somebody, what time you are available for support, 8 to 7 p.m. on all the bank working days. Okay, and responsibility, what are the things on such supports you will do. And then if there is a critical issue coming up, which is in category A, let's say critical, then the response time is 2 hours. Category B, it is 4 hours. C, it is 1 day. Based on the criticality, the response time is different from the vendor. And once they respond, how much time they take to resolve it. So in case in a day they will resolve it. See, this is critical because your system may be down. You want it to be out to serve your customers. So this is a very critical part in any service, software service. So that is defined here, and then AMC, if there is an enhancement, how do you do that? That's an SLA example. This is NDA. Okay, so between two parties, whenever you share some data, any confidential information, we also sign an NDA. I'll just leave it. Okay, so as I said, like, so see, this is basically we create an official contract between the client and the vendor, by using the requirements we received, the scope of work we defined, and based on the estimation, we create a business proposal with all these details, the terms and conditions, the cost, the payment schedule, and which is covered across different agreements like Master Services Agreement, NDA, SLA, Service Level Agreement, AMC. Okay. Any questions? So what will happen if it is not there? So that is where, if you do a business with somebody without an agreement, any business, like, end of the day, if there is a dispute coming up, these are the documents which will support you. So now, let's say in our case, if our client is saying, no, this is not what we wanted. So we have an agreement which he has signed and told us, like, see, this is what I want. So that's where, we cover a risk. It's always common. You develop a software, deliver it to the customer. Customer will say, no, this is not what we want, or there is changes required. So any change is cost. So we want to control that or limit that. So that's why a lot of process which goes on through these things. Just for your awareness, okay? So a little more on the software requirements. As I told you, when we get a requirement, we create some functional requirements spec. So this is something you need to ask the students to create. So whether as part of an assignment or as part of your mini project or project, let them create a SRS. This is simply an employee attendance and leave payroll thing. I'll show you how it looks like. So these are the modules. So you see here, this is a little more elaborated, wherein a mock-up screen is also included in the FRS to give more clarity on what is required, okay? So it says like, I need a login page with the login name, password, login, and forgot password. So that's a requirement, okay? So you can see that requirement number 6.1A is you should be able to enter a login name and password and click login button to log into the HRMS. Now this numbering is important. Why? So each small subtask or sub requirements need to be on a separate number, because that helps you in traceability. Now, see, once you develop the software, or the developer, let's say, this is the requirement document. Now, as a developer, I'm going to develop this software. So my job is go and write a program which, can enter login password, and then so it's clear, like, I need these two fields and the button to log in, and then it should log into the system. Okay. And there are additional rules. Your password policy is given. Okay. Whenever you enter a password, it should be minimum 8, should include one alphabet. Those rules are there. Expiry in 30 days. All that is specified. So when I go and code this, I know that these are the requirements, and I need to code for each of these things. Okay, so I can check, okay, I've done 6A, I have done 6B, I've done 6B, 1, 2, 3, 4, etc. Now, how does it help the testing team? So when they go and test, they will go and test each of these particular requirements. Individual requirements will be tested, and they will certify, okay, all this is working. Now, the next stage, when it goes to the end user, the customer will also go through this and make sure, okay, all this is implemented. So create a requirement document with very clear, specific, numbering, so that you can trace it. Okay. And we also use something called a traceability matrix for this. So whatever is there in the requirement, that means 6A is covered in design, 6A is covered in development, 6A is covered in testing, and 6A is delivered. Okay. This example, even the pop-ups, what message is required and how the button should look like. So it has got, more information, a lot more information. So this is, if you have a detailed requirement doc, it's easy for you to start developing or deliver a software which complies with all the requirements. This is a home page with the dashboard, all that. So all this is created using mockups. Okay. So let me go to the next one. So it's all about requirements and how important it is in a software engineering practice. And let me talk about requirements and user stories. Let me see if I have a sample for that. So this again, soft requirement specification. I think I can skip that. Okay, so this is the second part, which is this is the FRSA showed us mostly of waterfall model kind of programming, or you can use for both, but in the case of an agile Scrum development, what happens is we create stories. There's also requirements, individual requirements, okay, and these requirements or individual stories or tickets are taken for development, and then once development is over, that is taken for testing, and it goes on. Okay, so these are some of the examples for the second part. We'll close some of the things. That's my PPT. What happened to my PPT? I closed the PPT also? Did I do that? Sorry about it. I think I closed my PPT. Where were we? This one, right? Okay, so user stories, and one point, also I want to mention is always there will be functional and non-functional requirements. Functional means they may say like, I want to do debit credit, this is what functional requirement. And the non-functional could be like a company can tell, we want to develop it using open source, or we want to use our company's branding colors. So there'll be a lot of, other non-functional requirements as well. So when you create a requirement, make sure you also capture those information. Okay. Now, let me come to the design part. Okay. So the design, you can see that a lot of components involved in that. The first part is you have to, if the application is having a user interface, the first part is you go and design the UI. Okay. So I put both UI and UX because now, if you have an application, it's technically good and it's working fine, but if your user interface or the user experience, if it is not good, people are not going to use it. Like you have downloaded some apps, you tried, that app for some time, and you find it, not usable, or the user experience is not good. That means you are not going to use it anymore. So it's very interesting and very important that you have a very nice UI with a very good user experience. So there are people, specific people who can, create UI with the best user experience. This is one area, so many people working on. And the second part is, whatever we create doesn't mean that the customer may like it. So the second option is we create mockups in HTML. Mockups can be like, I showed you one kind of mockup, kind of a drawing, pencil sketching kind of mockups, or even create HTML, which you can click and move kind of mockups can be created. Okay, let's see if I have some. This is what. I need this. I think copied the wrong one. Yeah, okay. So I got, see, I will go here, give you some sample mockups. So this is like, this is normally done by graphic designers. They go and create the graphic design using PageMaker or things like that. So you can see that more on here, like all the GUI is designed using graphics. Okay. So that is first way of creating mockups. The disadvantage here is you can't pick, click and then traverse through the different options. Okay. So let me go to the next one. This is architecture. So add some HTML also, just thinking where it is. Yeah. So this one, if you go, it's created using HTML actually. Okay. So we have different methods wherein we can go and create. This is all each of the pages department. If you create department, how should it look like? You can see this is basically HTML. So you can probably go and see the look and feel. So that's the second way of doing it, and I'll also show you the mockup tool. This is a paid tool, basically Balsamic. So this is here, you have all these UI components here. You can just drag and drop, take this, you have labels, you have buttons. So this, why we use it is like, the customers won't understand, like when you're building it, you will build the whole thing, and at the end of the project, like let's say after 2 months or 3 months or 6 months, you go and show them something, they may not like it, like or they will say no, this is not something we wanted. So mockups always help you to convey what you are planning to the customers. So you can use mockups using some of the tools like Balsamic, or you can use HTML mockups you can create, or graphics mockups can be created. Okay. So once this is one part of it. And second is architects who designs the application architecture, like they decide whether it should be MVC or microservices, and what should be the overall system architecture, network, etc. So this is the second job. This is one of the highly paid one. Like after so many years of experience, you can become an architect. Architects are very highly paid. Okay, let's see some of the architecture. So this is one example. This is basically a Python application. You can see Python Django application using a REST framework, a REST API framework. And it also uses an ORM layer, which is, like object relational model layer, which for connecting to the database. Okay. And it also has cron jobs, background jobs running, which connects to an FTP folder, getting the data, and then pushing it to the database. And it also connects to an external service, SendGrid for sending the emails and other messages. And the clients are connecting using Angular. Angular is the front-end framework. So this is the overall system architecture. Okay. When you take even inside Django, the application or the REST framework, you then go to the detailed design of how your Django REST API should look like. What is the request parameters, what is the response parameters, and what are validations required. So probably I may have some more samples. So this, yeah. This is another, you can see a banking application. wherein customers connect via the internet, and there is a firewall in between. And then you can see one more firewall in between, before it reaches the database or the application servers. These are the public web servers. So the next challenge is creating an architecture which is scalable and which is robust, which is resilient, basically. Okay. So let me go to the backend design. So I said, like, if it is an API-based or service-based architecture, you normally need an API. I think you know what API is. Yeah, come here. So you can see, like, let me take the case of what are these APIs? Yeah, this is the login API. Okay, let me see login API. So when you try to log in, the method, HTTP method I need to use is post. And then these are the parameters I am going to pass. The parameters will be passed in the body. And I may be passing a header, in the header I may be passing a token. And then what happens if the API succeeds or it fails, and what is the URL I want to use? So similarly, you have all the, how do you create users? How do you list users? So you can see, like, all the API request methods, input parameters, success, what happens. So it's completely designed. So the developer will be going and, looking at the spec and then creating it. That's APIs. Similarly, you also create databases. You're familiar with, like, we design the tables, the columns, the type, the size, and what are the constraints on that. Okay, so this is master user, master client, all that is there. Okay, so the next step is database design. And sometimes, you also need to decide on the technology stack, basically. I showed you there, like in this one, I showed you the security technology stack was .NET in this case. So that we're seeing. So, here the option is, let's say when you want to develop, now in this era of cloud technologies and services, when you try to make, some application, you have two options, basically. One is you develop something of your own, or if that service is already available in the cloud, you use it. That means you can quickly make some application up and running using cloud services. So while you design your system, one of the questions is, like, whether you want to use cloud technologies. Okay. So this is something entirely using, cloud services. Okay, so you can see Cognito is an AWS cloud authentication component. GraphQL AppSync, another GraphQuery component which is running on AppSync, and it is using serverless, which is Aurora serverless. And instead of databases, we are using RDS. Okay, so you can see that the entire application is built mostly using cloud services. So design, currently we always look at that. And all this put together, normally we create a document called SDD, software design document. And this is something also, you can enforce students who have it in their project. When they do their main project, make sure they at least think about, the GUI design, they think about the architecture, they do some design on the APIs. First, they design before they go and start coding. They design all these things, and this, take a learn decision about the technology to be used, and then all put together into a SDD, software design document. Okay. Any questions before I go to? So now we have completed the requirements, and we created the designs. So the next part normally will be, like, we set up the project management. Anything you want to ask?
Sir, is there any
Sir, please go ahead.
steps like start with UI UX design and go with architectural design? or a design happen?
Sir, it was not clear to me. Like if someone can, it was voice was very slightly low.
One of them. So design can the UI UX design as well as the architectural design can be simultaneously happen, right?
Yeah, yes, you're right. That's right.
Team
So when it comes to design, it is in
both group,
parallel. Once you
both
have the
persons working
requirements
on
in place, yes, yeah, you're right. So in the project plan, it will, if you see the Gantt chart, it will be parallel lines. You got me. Like I'll show you a Gantt chart.
it. Okay, thank you.
Okay, so now we know what to do. We know the requirement. We know what to do. Now the next is like we need a team, right? So as I said, like we set up project management parts, wherein we decide a project manager, and then we decide a team lead or a technical lead. If it's a .NET project, .NET lead, or if it's a Python project, we'll have a Python tech lead for that. Based on the number of people, right? Okay, there may be multiple tech leads, multiple PMs if the project is big. And developers, dev, QA, that's a testing team, and then business analyst, also DevOps, finally to deploy the software. And people used to do the project management using Excel before. Now people are using online tool like Zoho, Jira. These are project management tools wherein you can go and create things and then start working on it. So once the team is ready, the next step is you go and create the environment. Here, see, if you see like in a normal individual development, you are taking your laptop and then start developing it, right? So that's how it happens. So in a real scenario, you need different environments. One is dev. That means where the developers are going and developing the software. Okay. And the second is once the development is over, the developed and unit tested software will be put into the QA machine or the QA server. In the QA server, testers will go and start testing it. And in these two environments, the data is normally junk data. Like you create some sample data and test it. And then when it goes to the staging, normally our customer will also be testing. And there will be more of realistic data, not necessarily the actual data, but it will be more realistic or backup or a scrap kind of data which is there. So once everything is okay in the staging, then we move the changes to the production environment, which is a live system. So before you start developing, you will make sure these environments are set up. Okay. And I've sent the link here. Let's see, what is it? Yeah, this is the cycle how it goes. It goes to development, testing, staging, production. Okay, you can see like it's used by developers, QA engineers, and it's by clients and arrange testers, and then finally, normally what this ensures is you will never have access to the customer data. You will never have access to the production system unless you just can monitor something. What is happening there. That's it. Okay. Now, once we have the environment, we have the project management team, you can decide on what model to follow. So we have waterfall model and agile scrum model. These are the most commonly used ones. So I just put only those two. Now, what is the problem with waterfall model? I know like this session was already over. So I just tell you the need. The need for this is like we have many experiences where before we develop like ERP software, let's say. We developed an ERP for a production, manufacturing company. And we developed it for around 6 to 8 months to make the first release. Okay. We made the first release and then they said so many changes and the changes started growing and they started saying, no, this is what we wanted in production. This is not what we wanted in finance module. This is not what we wanted in HR module. Lot of conflicts basically. So when we say that even if though we have the agreement, they will say, how do we know? We are not technical. Okay. So it keeps going. The project extended to 1 year, 1.5 years. And meanwhile, the business people from the client side, they resigned, some of them, like the production manager or the HR manager. Some of them resigned and some new guys came in. They had other ideas, new ideas, or they bring in some process from their previous organization and they wanted to implement that. Now what happens again, you need to go and change. See, the project got extended and we were never able to deliver it to the satisfaction of the customer. So now you see, you have worked for 1 year, 1.5 years. At the end of the day, you're seeing that you're not meeting the customer expectations. That was one of the biggest challenges with waterfall models, because you don't make intermediary releases. You make something, deliver it, let the customer say it is okay or not, then go to the next. That's a difference here. You can see the diagram basically. In waterfall, we do everything. We do the requirement, design, implementation, testing, and then delivery, and then deployment and maintenance. But in the case of agile, what we do is we have few backlogs. So we have a set of stories which we want to do, a set of cards which we want to move to the development. So we analyze that, and then we take it to the next level, the design level, testing level, and then deploy. So this duration is very short, like 2 weeks, 3 weeks. The duration we take, let's say 4 tasks, we develop it, deliver it. So what happens once you deploy, the client tests, and there is a process called user acceptance testing. So they test it and say, okay, this is fine. So this is the second method, and mostly all the projects are now using Agile Scrum. Okay, so I think there was a session, so I'm not going much detail into it. Let me see if I have any related. So this is something I told you, the Gantt chart. Okay, so in this case, you can see it's a waterfall kind of thing, wherein we do some 5 days for the requirement analysis and then design another 10 days. So you can see that it's just set as design. So everything goes together here. And then some 75 days for the development, testing, and release. And then final deployment and testing 2 days. And then this is the UAT. So this is the Gantt chart kind of thing. Finally, you get what are the activities which can go in parallel and what are the activities which will go in sequence. So this the chart helps you with that. And this is another one. You can see that here you can see that there are multiple projects, okay, done by multiple teams. For example, this is a migration of the which required because the application was dependent on IE, Internet Explorer. Some of the versions are now outdated, so they wanted to test and migrate their application to Chrome browser. Okay, so that happens here, and you can see that in parallel other activities are happening, like load testing is happening, and this is another development which happens here. But there was some dependency, so it is moved to after November. So this kind of graph helps you to identify what are the parallel projects going in parallel, what is the time when you can get the releases. Now this we already saw Agile Scrum. This I hope it is covered, right? I can skip. What do you think? So these are the activities basically, for there'll be a product owner. So they'll keep, collect requirements from the customers, team managers, etc. Put it into something called a backlog. From the backlog, there'll be a meeting, like, sprint planning meeting will be there. In that meeting, we will take out, for the next sprint, let's say 2 week, this is 1 to 4 week, let's say 2 week sprint, we will, out of this, let's say we are taking 1 and 2. And then we will move it to the current sprint. So this is the same thing I talked about you, which works in here. There'll be sprint reviews. Once it is finished, it is delivered. And this is to see what was the problems incurred in during the development. Okay, so the whole thing is managed by something called Scrum Master. Okay, So that's agile. This is what is followed now most of the companies. Okay, rather than see this happens to you also. Like like some of the students at the end of the semester or they'll come and say, like we lost our code, or there are no results. So even if they use the agile and they create sprints and deliver it and show it, test it, review it, that has more kind acceptance. Okay, so now we are set with the environment, the requirement, the design, and also the project management. I mean, basically, the team is set up. Okay, so now other thing, like in a project, let's say 4 or 5 people are working. They are working on different areas. Okay, and then finally you want to integrate this code into one and then deliver it to the customer. Okay, there are several problems in that. One is how do these independent developments happen? How do you integrate it? Okay, what is the process for that? What is the best process for that? Or what happened when they lose their source code? This again happens, like students come and say, I lost my code or my laptop crashed, so I lost everything. So this is one of the first thing, before they start their project or development, they make sure they have a source control in place. That means their source code is version controlled and kept in a repository like GitHub, GitLab, or SVN. SVN is open source. These are online ones. Okay. So how is it done there? Let me go to sorry, this you already covered. Let me skip that. So how does the Git work? So this is part of our second session, in fact. Okay, source code management. Like this GitHub is a public server where you can maintain the source code. Okay, and these are the different people working on it. So they can take the code from the repository, download it to your local machine, make changes, and then commit it back to the main repository. Okay, each one can do that. So then there is a risk, right? People may change different things, and when you put it back, there will be a lot of conflicts and other things, right? So there can be errors and mistakes. So there is a process normally followed in the case of the source code management. Okay. So what we do, normal steps, I'm just telling you how, if you want to use Git in a proper way, like, these are the steps. You will normally get a Git account. This is a public one. Go and take an account, create a Git repo, and then set access rights, like how do you want to manage your Git repo. Now, if you already have a code, you can push it if it is available. Or so now let's say you have some code you already developed, you put it in the Git, and then now 3 people are going to work, okay, on 3 different features or 3 different modules or different areas. So he can do something called create a feature branch. So I'll come to this diagram. You can see here, this was a master branch, the main code. From here, I created a branch, feature branch, okay? Then I'm making changes here. I do programming every day. I do commit, and then at some stage I tested and I'm okay. I will send a pull request, okay? Pull request means before we merge everything to the master, somebody will review and see, okay, is all the changes okay? Is it mergeable or is there an issue? And then this, probably the reviewer will send some feedback to the developer. It keeps happening that. And then test these changes. If everything is there, we will merge with the original code. This is how the source code is managed. You can see that during this time, when a developer is making these commits and changes, there may be already changes made by others. It's all in place. Okay, so that's why I said when you are going to work, create a feature branch, and you have to install Git on your dev machine, configure Git, set the name, email, all those things. You can check out a feature branch, which means you download here to your machine, and then you create or update the files. Everything is done locally, okay, on your machine. and then you commit the changes locally and push your code to the GitHub, send a pull request. You will ask your manager, sending a pull request, please review and merge it. So the manager will review the PR and merge it. Okay, so this is how the GitHub or the branching works. So this is again, one of the important factors. Writing code is, and then if you can't properly manage it with version control, like let's say you created some code, it's making a break, breaking the system. So you can revert back and then take the previous code and then deploy it. Okay, so this is the coding part of it. So as a developer, you also need to set up your environment. Let's say if you are going to develop on Python or Java, you have an operating system, say Linux. You set the required compilers like JDK or JRE, and then put an IDE, development, kind of editor where you can easily develop and integrate code. Install the database, maybe Postgres or MySQL, whatever is the database. Then set the access permissions for the different areas. Sometimes it is remote desktop because the client want to make the development in their server, in their data center. So what they do is they give us a remote desktop. Like from here we connect to their machine and then work on that machine, make all the changes in their machine and then deploy in their server. That means they don't allow us to take any of the code or any of the details out of their network. The only way we can work is like remotely connect to their desktop and work. Okay, and the developer also has a duty of unit testing it. So once the coding is done, he himself need to unit test. It means he has to do the testing of whatever code he has written, like wherein we teach them the boundary cases, the normal valid cases, invalid cases, all that need to be tested. And in many companies, this unit testing is done using scripting. That means along with the code you write for your application, you also ask the developer to write the testing script for unit testing it. That means when you take the code to the, let's say I showed you that in the Git repository, you can also test, you can run those scripts and test. Everything is working fine or not, right? So they'll do these things, their deployments. That's development part. Any questions here? So now at least, now when we develop or when they do the project or learn the things, most of these essential, components are not used. We skip that. So what happens, these things, they are not aware. So when it comes to a company, first they need to learn all these process, all these tools, all these things. So once you develop, it goes for testing. Okay, testing, like functional testing is where I'll take the requirement document, I know the requirements, I'll go through each of those documents one by one. Okay, so for functional testing, normally we create something called test cases. Let me show that. Test plan. So I'm going here and there, sorry about it. So you can see they create test cases or test scenarios. This is what the QA people do. Okay, so what they do is, you can see here, they create a test plan. That means how many days they are going to take, how they are going to do the testing, who are all the people who are going to do the testing. So all that they decide in the test plan. Then they create a test case document. That's what I'm showing you here. This is a test case document. Okay. So they will define what is the test case, what are the inputs to be given, like all this is. And you see expected behavior and test result. What is the result they got? If there is a bug, they will assign to somebody. So this also act as a bug tracker. Okay. So for all the requirements in the requirement document, they create test cases. There'll be thousands of test cases sometimes. And they go through the testing. Each time you make a change, the testing people need to go through each of these test cases and make sure all the test cases are passed, successful. Okay, so that's functional testing part. Okay, and this testing, like I told you, it's thousands of test cases. Every time you make a change, this need to be run. That is a lot of time consuming thing. That's where we use the automation testing. You see the last one, automation testing using some tools like Selenium. So there are specialized QAs who does functional testing, who does law testing, security testing, or kind of automation testing. This is specialized area, like people get trained and certified in automation testing. They write scripts. What the scripts will do is, like a human being going and testing an application, these scripts will automatically run and do the test, and it will also get you the results. Okay, so that way you can save time in deployments. Security testing, load testing, this is what happened when we released one of the recent apps, mobile apps, where, people started logging into that app simultaneously. So it was not able to take that much load. It happens many times, right? So to avoid that, once your application is developed, completed, deployed, it's always good to do a load testing. What is the capacity of your software to bear the load? You can see this is one sample load test conducted on a software, and it says, how many active threads all the time. They also tell you per second individual customer how many customers can be created per second on the system with a given hardware. Transactions per second, how many transactions it can perform, and what was the CPU utilization on that particular one, and how was the database server performing at that time. And then normally they also give a conclusion, what are the things to be done, any recommendations. Okay, so an example of load testing can also give you something called vulnerability analysis. I hope you know what this is, because sometimes what happens, we develop an application, there will be vulnerabilities wherein the hackers can go and attack our system. Okay, so we also do kind of security testing in all the critical systems. So you see, an application was analyzed, and we can see there are some percentage of low risk vulnerabilities existing in this application. This is a snapshot from a report, and it says, like, when they did tests like injection and different type of tests they do, and what are the tests passed and what are the things requiring fixing. So the software security test tells you what are the things where you have to go and do the testing. Okay, so this is another example. You can see that there is a possibility of SQL injection in this particular system, and the severity, basically it is high, critical. Okay, and direct object, no password management. So all that is identified. This was in a very old system which they were trying to migrate. So they found like there are some gaps. Automation testing I talked about. So this is test plan, test case, test result, issue tackle, test vulnerabilities. Let me check that. So I told you this. Now you see, we started from a business requirement. A customer says, I want a login. So we created an expanded functional requirements, and we want to make sure, okay, on the design, we taken care of these things. Means the login, okay, in the middle tier, we have an API for logging in. For good login, we have another API here. And for login, we have the database tables for login. All the tables are there, And then we also make sure, okay, these are validations, enough validations like login. All the validations are handled in these particular APIs. And this is tested using these test cases. Okay, this is for us not to miss anything from the requirement, or to give a traceability starting from the requirement to design to testing. Okay, so some of us, we also create this part. Okay, so our software is ready. Okay, so we developed it. Any questions before we go to deployment? I have only a few slides. I hope deployment is the last part and operation. Okay, I'll complete this also, then we can talk. See, once this is ready, I told we need to deploy, right? You made everything ready in development, and you tested every in QA, and finally it has to go to the production, right? So it requires you to install, configure, and run the software. That's basically the deployment, right? So you made a program, and the program, along with all the dependencies, should be moved to a production environment, and we start running it there. Okay. So here is a problem. The problem is, say, I have a big application running in the production environment, and I made a small change. And I want to deploy this change to the running production system, live system. Okay. So how do I do it? I do it manually normally, right? I will go there, I'll shut down the server, I will shut down the applications, and then I'll copy the code or changes into that server. And if any reconfiguration required, I'll do that also. And then I'll restart the server and applications. Okay. Now, what is the problem? There is a downtime, right? So maybe I'm doing it in a weekend, but still 2 hours or 3 hours, the system is down. So we're getting a downtime for the system, one. Second, when I am restarting, I'm finding like there is some problem. The system is not restarting, or it's not coming up, or it's not performing as expected. Now you have the challenge of roll back the entire thing, right? So the changes you need to roll back, and then bring back the system to the previous stage or state. So that's a risk, right? High risk. You have a downtime. You have chances of manual error, and you don't know what will happen there, right? So to avoid these things, and then or to reduce the downtime, what we can do is like something called continuous integration and continuous deployment. Continuous integration we already talked about using Git. I told you multiple people can develop code in parallel, and then this can be integrated. Now, as and when you make the change, you commit, send a PR, it gets integrated to your original master code branch. Continuous deployment means once you are ready, the merge, everything is ready, you should be able to deploy the software very fast. Okay, so it need to be automated. So continuous deployment requires tools, and then which can automate the entire process. Okay, so this is one thing, continuous deployment of applications to the environments. It can be cloud, it can be on-premise, and we use tools, different tools for doing this. I'll show you some of the tools. And this I'll go to the thing and say, let me hold on these 2 points. And once it is deployed, now you say you have everything okay, it's up and running. The next step is, once it is deployed, you want somebody to operate it, right? Operation and monitoring. That means somebody will be monitoring the system. There'll be dashboards or log reports or alerts which tells you, okay, memory is going out of thing, or there are some problems, some part of it is down. So operation is important. So development, deployment, and then you have the operation. On the operations side, what you do is normally monitor if there you need any changes or anything, you make it. And they also do the updates and patching. Like, there is a security patch coming in the OS side, they'll go and apply it. And then there are updates coming from the development team. They will stop the server and make the updates. So this updates and patches normally will have some downtime. And there are any errors, as I said, they will have to roll back to. And the other thing is they need to make sure compliance. Your system is running perfectly okay. You want to log all the transactions. You have to log all the errors, etc., and create audit entries, because that is required for some of the compliance, like RBI, let's say, they need certain things from the servers to audit it. We need to make sure these logs are generated, these records are generated, and it is available for audits. So deployed, and then it moved to the operation, which is the maintenance, I would say. So these are the points I said. So when you have a manual deployment, you have to manually set up the server, set up the environment, set up all the applications, configure it, test it, and make it to live. Okay. The problems are when there is a new change. Now we call it change management. It can be a feature or new releases or bug fixes. When you do it using a manual setup, it takes time. And there will be downtime. There can be errors. Manual errors can be there. In those cases, we need to roll back. So these things are normally done by two different people. So when you talk about change management, on the development side, I do the bug fixes, or I do the new feature creation, etc. Okay, but the deployment is done by another team, right? So we have a development team who wants to push their releases quickly. Okay, that means, so the customer, again, customer asking for a new feature. So I went and designed it and developed it and then ready for release. Okay, so I want to push it as early as possible for the customer so that the customer gets the service. But the operation team, on the other way, what is their objective? They want to keep the system stable, running, zero downtime. So they normally, what happens is they will try to delay these deployments. Okay, delay any changes to the environment. They are opposing it basically. Now you have two teams, the development team and the operations team. The development team want to push the changes faster, whereas the operations team want to block that. Okay, that means now we have a conflicting objectives as an organization. So to resolve this, is where we have the DevOps thing came into picture. Okay, before that, I'll go over the CI/CD a bit more deeper. So what is the objective of this CI/CD pipeline is to deliver new features and bug-free code at high velocity. Means that's what I said. We want to fast, go to the market very fast. We want to quickly and frequently make releases to the end customer. So how does it help? So this is the automation. So these are the stages, and you can see on the first two stages are continuous integration. So they're committing the code review, build, and unit test. This is, I told you in the Git part, right? So the CI part is enabled using GitHub or GitLab, whatever it is. So this is the dev side. On the ops side or the CD deployment side, what happens is the environment's set up, whereas you need all the infrastructure to be set up. And this is normally done using infrastructure as code, IAC, infrastructure as code. That means we are writing a script to create or build this environment. So you want a virtual machine in the cloud environment, you can write a script, the script will go and write it. Create it. Okay, we are not manually going and creating infrastructure or manually setting up networks or manually setting up for nothing. You don't go to the server or the cloud. You do everything using scripting. There are tools to do that. So that's called infrastructure as code. And then you are deploying the new build, okay, to staging, QA, or production, whatever environment you want. And then you are running the test there and verifying and then monitoring. That's operations side it goes. So this is the cycle of CI and CD, and this entire thing is automated, okay? Because of this automation, we get all these advantages like, faster time to market, reduced cost of ownership, reduce human errors, because this pipeline is entirely automated. So there is no chance that somebody goes there and make a change which is not required. So it improves reliability. Lot of things are happening here. And this is how, like some of the sites you never Google, let's say, whenever you go there, the search engine is up, right? It is never down. So they have, but they are making changes. You see also make some changes suddenly happening, but you never found it down. So they have a complete automated CI/CD pipeline, which enables them to, do these changes anytime with fraction of, in minutes or, whatever it is. So you get, availability, which is 99.9959. Okay. So I slightly touch upon DevOps. I said like there is a conflict between development team and operations. So it's a culture change wherein a group of people who will also do some part of the development and the operations. They are responsible for both. That way, the conflict can be reduced. So you can see here in another way, the dev, what they do is they plan, they make the code, build it, test it, and then the release, it is raised and deployed, operate, and monitor. So these are the two dev and ops, so this is a group of people who will do, it's not purely monitoring. They will also do programming, and they will go and make the required changes. So they ensure, they know how to build the system, how to run the system, how to make changes to the system. So this also gives a lot of benefits. It's a very hot topic now, and a lot of opportunities for DevOps. The resources are very less. You're not finding it. One of the company I work for is, mostly doing DevOps platform, services. Benefits, as I said, the entire automation, and then once you have automation, you are not bothered about how deployment and other things happen. So you get time for innovation and productivity, and there is no conflict as such. So better work environment. This time, fail fast, fail safe. So you made some changes. You are able to deploy it in minutes, and then you find like there is a problem. It failed. Okay, so it's fail fast. So since you fail fast, there's a problem. You can revert it back. Okay. So this is one of the technique, there are some changes to make. It is always better to fail fast rather than, you fail after 2 or 3 days or, weeks. You see like, your deployment had a problem. So you can't revert back, right? A lot of transactions must have gone already. That's a big thing. And when you automate, definitely it reduces cost and errors. And security, like nobody is entering into a server to do something, so though there's no manual intervention, that gives more security. So in any port or any access you allow, it's always a risk. It's also always an opportunity for these people like hackers. So you'll also find some of the similar terms like DevSecOps, which is DevOps with who also take care of the security, and one of the latest is AIOps, which is basically these operations. Like you learn from the errors, you learn from the problems, you analyze, and then you recommend the changes automatically. So AI can be used to make it better. Your operations, your deployments, your resource utilization, all that can be made better by using some of these AI tools and technologies. Now, let me tell you overall how it works. Okay. So this is one diagram where this is developers. Okay. So this is our operations team. So developers check in the code to the GitHub. Okay. and the operation team will add additional things, any of the additional things they want, they will do here, and we take it from there, and it's called a GitOps engine. Or what does it? It does it pull the code from GitHub, validate it if it's okay, and then create the build. Build means if it is a Java program, you build a WAR file. If it is a Microsoft program, maybe you will create an exe file. So that's a process is the build. And then you will also scan the code for any security or other vulnerabilities. So scanning happens, and then you will sign the code to make sure it's secure. And then you push it to a temporary repo. And finally, what happens, the deployment manager takes this code and deploys to any of the environment like dev, QA, or production. Okay. Now, you can see that the entire process is automated. The developers are sitting here, operations team is sitting there. They make only changes in the GitHub. All other things are automated. So these are all scripts or tools are used to automate the entire process. Okay, so this is once it is deployed, as I said, like we need somebody to observe or monitor it, right? You want to see any problems there, so you connect it to an incident management system, or there'll be SREs or DevOps to resolve it. That happens in here. There'll be a dashboard to see all these things. And these can be either to on-premise servers or to multi-cloud, any of the cloud environments. Okay, and sometimes once the code is built, you may need somebody to approve it. So you can also link some workflow engines so that these approvers will approve. After approval only, it will go to your environments. Okay. So this is the this component. This is the CI part, and this is the CD, continuous deployment part, which happens to different environments. You can see here, like once you have this pipeline implemented, then you can do it into any servers, right? You don't have to manually go do here. Nothing is required. It happens, stream. All right, so that's it. And probably I may have one more thing. I don't know how far it will help you. Yeah, here it is. I talked about this. Container. You want to go through containers? I can just give you what it is, if you're okay. Okay, so see, the traditional way of running applications is you go to a PC, get a hardware, and in that hardware you install everything and run it. That's how the traditional way of doing it. Okay, and now currently what we do is in the cloud and all, like we can go and get a virtual machine. So what is a virtual machine? Like there's one big physical hardware where we use that's infra, and we use a hypervisor. And then we create let's say here, three virtual machines. So 3 OS installed. One may be Windows, one may be Linux, one may be Mac or whatever it is. You can have multiple virtual machines in physical hardware. Okay, so you can see that in this OS, some applications running application 1, its libraries, etc. This application 2, 3. This is a second way of using bigger hardware, creating virtual machines, and then running applications within that. Okay, this is slightly heavy, and it uses more resources. And also, once you, for example, this hardware, let's say you had 32 GB RAM, and I allocated 8 GB for this, 8. So once I allocate that memory to these virtual machines, I cannot reuse it. It is hard and fast, like I gave this much disk and memory for these VMs, and the VMs, whether you use it or not, that's it. So if you go to the cloud and take a VM and take some capacity, compute and storage, you are charged for that, whether you use it or not. And the next way of doing it is, you can see the difference here. you can hear there's only one OS. Here, if you see 1, 2, 3 OS for 3 applications. Here, it's only one operating system. And then we run a container engine, and the applications and binary are in containers. So this becomes 1 container, 2, 3. So now you can see this is light, and the resources are not statically allocated. So you can dynamically grow or scale up or scale down. That's possible for these things. Okay, so that's it. And what is the difference? Containers, as I said, containers are lightweight, and it provides OS level virtualization. On the other side, the other one is providing hardware level virtualization. Okay, and every container shares the same OS, and it requires less space. It is faster, and you can do it very easily. Okay, there are very good, and one of the main thing why people use this is now the cost. Like when you have resources on the cloud, if you are deploying your application as a container, your resource consumption will be lesser. Your capabilities for scaling up and scaling down is also better. Okay. Now, above this, now we'll say you have so many applications, hundreds of applications as part of your system. So all this needs to connect, right? And then communicate. They need a network. So that means you need an orchestration layer on this, container ports. So that's where Kubernetes comes into picture. So Kubernetes is an orchestration layer, So you can see here on this node, that's a hardware, you have different ports, and in each port you have multiple containers. Okay, these are Docker containers, Docker images and Docker containers, and here also same. And this is the control plane or the master. So this is a cluster basically. So we have cluster with 2 nodes in the master, and in the master we run all the schedulers, controllers, and everything in the Kubernetes, and people connect to this cluster, Kubernetes cluster, using an interface, or there's a CLI command line, kubectl. So you can use that to connect to this control plane. So this is how now the modern applications are deployed to cloud. People started migrating their applications to containers from virtual machines or VMs. Okay, so that's just a brief. Kubernetes is a complex and difficult subject to learn, not very easy. But the concept is this. Okay. Come back. Yeah. Where is my PPT? I think I'm almost done with that. Yeah. Any questions now? I just try to, cover how things are done in practice. Okay. So that may help you in some way, like to advise your students or, to make them understand. So it's up to you to include how you want to include it in, some of the subjects or some of the assignments or some of the, extra learning. Okay, sir, we can go ahead.
Hello, sir.
Yeah, sure.
It's a good presentation. I have got few questions regarding the cost valuation of a particular software development.
Okay.
The very first section there.
Yeah.
How the cost is being evaluated, what kind of metrics that it is good to follow.
Yeah, I showed you the simplest one. There are different analyses, like sometimes we calculate how many functions are there going to be there in the code. In this case, it's mostly we have worked out into 3 layers. Like now currently every application is built as a front end, middle tier, and a back end. Okay. So now start with the backend. We know like to create a login page, we need to create two tables. We need to create one procedure, or we need to create one trigger or whatever it is. Okay. So we know what is to be done there. Now for a database developer, we know how much time they are going to take. Now, again, that based on the experience of the developer, it changes, but we average it. Like we say, 4 hours for a DB developer to do this database part. Now we come to the middle layer where we know we have to. I showed you like we need two APIs to be developed. One is a login API, where are there only two attributes, login and password, and there are a finite set of validations, and then we need to give the response back accordingly. So based on, we'll go into those details, and for each details, we put how much time if somebody goes and develops it, they will take. So it may not be exact, accurate. That's why I said sometimes we also add a buffer, 10%, some buffer will be added to that. And then we go to the GUI side. GUI side, normally we count the number of fields required, and also the type of the field. Some are a text box. It's easy to make it, but it's a combo box. Let's say it's a select list. Now you need an API to call the backend, get the list values, and then populate it on the combo. So each of those that is analyzed, and then there are engineers. So normally we give it to the engineers, and they come back with some figures. We review it. We ask them how do you arrive at. That's how currently we have done that. And for bigger projects, it's very difficult. And for agile thing, it is during the Scrum meeting, preparation meeting, we take each of this, and then there'll be technical leads involved in that. They come up with a number.
Who is responsible for making this? Is this business analyst or team lead?
Estimation normally goes to the PM and tech lead, because they are the real implementation people. BS are now more of a kind of domain knowledge, plus they know some technology. That's their skill set normally.
Particularly in that estimation, in what proportionate we will take the values for testing?
Yeah, normally it is 15 to 20%. That's a rough estimate we take. It can go up to 30 if the application has so many integrations. Like in the backend, it connects to Active Directory, it connects to some other external systems. Then it takes time to test it. It can go from 15 to 30% based on the complexity of the application.
Okay. One more question regarding a master service level agreement. Is there anything that we need to follow upon, any IT rules or IT acts that are existing in India?
Yeah, and normally we say the jurisdiction. That's one thing, and the second is, let's say the particular software requires some compliance. Say when you create a banking software, there will be an RBI, compliance with it. When you do some insurance or when you do healthcare, there are compliance like HIPAA compliance. So we need to tell them this complies. The software complies with all these rules. That has to be there in the agreement, and they also will ask us to get certified. So that's how a software becomes HIPAA compliant or RBI compliant.
Okay, sir. Thank you.
Any other things? In an afternoon, everybody must be sleeping now. Usually.
So one more question from DevOps.
Yeah.
Do we need to interchange the developers and operation teams frequently?
No, actually, the idea is developers are good at development. Let them sit there and develop things. Okay, let them not worry about how this is going to be deployed. How am I going to build it? How am I going to put it into QA? Let them don't worry about it. the idea is like developers will be concentrating on their development and innovation and those things. So they don't want to know how it deploys. That's what it is. It's the team, a separate team who also has got the development knowledge. That's the difference. Before it was purely, operation team was monitoring. They will look in the screen and say, oh, there is a problem here. And they will go back to the developer or somebody else to resolve it. That's not the way things are done.
Okay, sir. Thank you.
Now people start talking about AI ops and ML ops. What's the difference?
Yeah, that's a new thing where now some of the products are coming up with those things. They are. It's based on like they see when it goes to the operation, you get a large set of log, I would say, how your processor is utilized. So you may find some spikes at certain day, certain time. Now, these kind of software can find out when is it happening. So now even that software can recommend you, okay, on Friday evening, 4 to 5, you need more resources, like, more CPU, more, compute for you to meet your load requirements. So that's one. And log, they will analyze the log and tell you, any patterns, specific kind of patterns which is happening in the background. Any kind of, jobs are repeating or giving errors. So it's huge, this data, basically the log data is huge. So there are some policies, retention policies, some of them say 3 months you need to retain all the logs. So you can do, kind of analysis or apply artificial intelligence to these logs and derive at so many conclusions or recommendations. There are systems now, doing that. That's a growing area.
So these are basically AI ML apps which runs in the operational environment.
Yeah, exactly. Yeah, it collects the data from there. It collects the data from there and then makes these recommendations.
But the development and the deployment happens in a normal way, like DevOps, right?
Yeah. Yes. That is an addition. After deployment, they collect data from the servers.
Okay.
So the monitoring team only used to monitor, right? Whenever there is a problem, they will say there is a problem. That's it. This is not like that. Even these systems can tell you, there can be a problem on this date or this time, usually. Predictions are possible.
Okay, thank you, sir.
Okay. That's all.
Dear participants, any more questions or feedbacks?
So it was really an excellent presentation. You could compress everything regarding software engineering and project management in just 2 hours. And we could get more clarity on even the topics we have already covered yesterday and today morning. You have made it more clear. Thank you very much.
I purely wanted to, tell you, see, I worked in a campus college for some 6-7 years, I guess, and then I moved to IT.
Yeah,
So I just wanted to show the other side, how things are happening here. So you'll get more clarity on, why all this is required.
Yeah, we can see that field of difference. One person having both academia and industry coming and talking.
Yeah, I still like to do some academic activities.
Okay. It was a very informative and very beautiful presentation, as Matthew sir already mentioned. Thank you very much on behalf of Department of Computer Science and Engineering, because he is a part of Board of Studies already. So, I extend my sincere thanks to Dr. Anil Kumar for delivering such a beautiful lecture.
Thanks everyone for the time, and need any help, let me know. Salim knows my contact details.
Okay.
So my pleasure for having this chance and then talk to you all. Thank you so much.
Thank you very much.
Thank you. Bye bye.
Thank you. We'll be winding up the session, and tomorrow morning 9:30 in the next session. Next session is about day 3. It is Agile Software Management framework, Scrum framework, and tomorrow evening session it is taken by Praveen Nair and Tarin Kumarchi. So tomorrow morning 9:30, please join. Thank you all.